Hello friends, today's question. A drop of liquid of radius r 10 to the power minus 2 meter having surface tension S 0.1 by 4 pi Newton per meter divides itself into k identical drops. In this process, the total change in surface energy, that is delta U, is 10 to the power minus 3 joules. If k is 10 to the power alpha, then the value of alpha is. So in this case, we have a bigger drop, radius r, it divides into k identical drops. And we know that the surface energy is surface tension multiplied by the area. So we are going to use this basic concept, first of all for the bigger drop, and then we are going to same for the smaller drop, and then we are going to equate them and find out the initial and final surface energy, and the difference is given as 10 to the power minus 3, and this will help in calculation of value of alpha. So let us start with initial surface energy for a bigger drop. Initial surface energy. So for the drop of radius r, for drop of radius r, its surface area, or rather we can say initial surface area, the surface area, let us call it as AI, and that will be equal to 4 pi r square. Therefore, the initial surface energy, the initial surface energy, let us call that as U of I, will be equal to S, that is a surface tension multiplied by the initial area. So therefore we can write that initial energy is equal to S multiplied by 4 pi r square. So this is the initial surface energy when the liquid drop is in a hole. It is not being divided into identical drops. Now let's find out the final surface energy when it is divided into smaller drops. And before that, we are going to find out the relationship between the radius of the bigger drop and the radius of the smaller drops. Okay. So let us find out radius of each small drops after division. So we are given that when the big drop, which basically means initial, splits into k identical small drops, k identical small drops of each having radius as small r. Therefore we can write that the volume of each small drop will be equal to 4 by 3 pi r cube, and we have, you can say, k small drops, okay. And we can also say the volume of the bigger drop, volume of big drop will be equal to 4 by 3 pi r capital cube, and this big drop divides itself into k smaller drops. So we can write that volume of big drop is equal to k times volume of small drop. We substitute the respective values. We have 4 by 3 pi r cube is equal to 4 by 3 pi r small cube. 4 by 3 pi goes away, so we get small r is equal to capital R k 1 by 3. So this is a relationship between the radius of the small drop as well as radius of the capital drop. Now we are going to find out surface energy of small drop. Surface energy of small drop. For surface energy, first of all, we need to know the surface area of the small drop. You can write surface area of small drop. Let us call that as AS, and that will equal to 4 pi and small r square. And we already know relationship between small and capital R. So we substitute it here, we get surface will be equal to 4 pi, and we have capital R k 1 by 3, and this is our whole square, which comes out 4 pi r square, and this is k 2 by 3. And we have k smaller drops, so therefore the total surface area of k small drops for k small drops, the total surface area, let us call this as 80, and this 80 will equal to k multiplied by surface area of each drop, and which we just found out k is equal to 4 pi r square divided by k 2 by 3. So we get the total surface area of all the k drops will be equal to 4 pi r square, and this becomes k, and it will be equal to 1 by 3. So therefore the final surface energy or new surface energy of all the k drops, you can say new, we can call this as final surface energy, let us call this UF, will be equal to surface tension multiplied by total surface area. So we can write this as UF is equal to S multiplied by 4 pi r square and K 1 by 3. Now we are given in the question that the change in surface energy is delta U, which is UF minus UI, means final surface energy minus initial surface energy. So change in surface energy, that is our delta U will be equal to final minus initial, and delta U is, let us substitute the values. Delta U is equal to final is given as S 4 pi r square k 1 by 3 minus, and initial is given as S 4 pi r square. So we can take 4 pi and S, sorry I missed here 4, so we can write this S 4 pi r square, and this becomes k 1 by 3 minus 1. Now we substitute the value. Change in energy is given as 10 to the power minus 3, and we have this as 0.1 divided by 4 pi multiply by 4 pi, and radius is given as 10 to the power minus 2 whole square, and this becomes k 1 by 3 minus 1. 4 pi goes with 4 pi, and we are left with 10 to the power minus 3, and this becomes 10 to the power minus 4.5, so this becomes 10 to the power minus 5, k 1 by 3 minus 1. So we can say k 1 by 3, so k 1 by 3 minus 1 is equal to, this will be coming as 10 to the power 2 means 100. So therefore we can write that k 1 by 3 is equal to 100 minus 1, sorry, plus 1, which will equal 101. Approximately we can take as 100, and it is given in the question that value of k is 10 to the power alpha. Okay. So let us first of all find out this k from here. K will be equal to 10 to the power 6, and k is given as 10 to the power alpha. So you can say 10 to the power alpha is equal to 10 to the power 6, so which means our alpha is equal to 6. Okay, so this is the value of alpha which is required. This is value of alpha. So this completes the question. Thank you.